Hello, welcome back to LIVENODING. In this episode, I'll be sharing with you the breakdown of these nodes, basically kind of similar to previous live noding. So we have a stack of boxes, but we have this ability to kind of randomize the box. There's one that's looking like a sphere, but that's actually also a box. If I scale it, I think the base, I need to kind of make it so it's always started at the base. See, the origin is always need to be set to the bottom. So the way I set it up is basically, I think I use the bounding box and look at the size of each object in the z-axis, and then I'm using this NumPy array to accumulate the sum of each height and then kind of stack it, kind of like offset it slightly. So it's a very simple setup. It might need a little bit of explanations, but so anyway, I have only three different boxes. So that's the first one, right? I can adjust the z-axis and everything will adjust accordingly. The one that's been subdivided is really originally it's just a box. Also, if I remove the offset, it's gonna perfectly fit at the bottom there. So we can specify how many boxes we want. Randomize the seed, so every seed that's being generated, let's say we have 10 over here, we can randomize the seed. You can see this is the seed 0, 1, 2 randomly generated. And oh, okay, I have this scale offset. It doesn't really work. Okay, save this very quickly. So the result is all these boxes that you can merge into a single object if you ever want to use geometry nodes with it. So let's take a look. The nice thing about SphereChalk is that you can merge the object into a single object. It's just like a join geometry for geometry nodes. So if you want to have like a multiple variations, you can duplicate the nodes. Ideally, I make use of SphereChalk grouping, which is can be handy. So I created a copy and I randomize. So we can use this heart. As arm and legs. Oh, I don't know why it always gets a bit slow after I record. After I start recording. So anytime you want to make changes, okay, it resets itself. But that's I think that's okay. That's actually okay if you are using geometry nodes to set the positions. It's always gonna reset to the position of the pivot. That might be actually what you want. So we can create this kind of structure. So it's kind of that's basically what it is. I mean, if you do 3D and involving a lot of assets, and even like if you want to make like a building, like a series, I think the ability is to just stack levels, multiple different variations of the geometry is gonna give you kind of complexity of the city. Or in this case, I'm always thinking, okay, I want to make like a character, like a robot. How can I do that using this nodes? All right. So yeah, I guess there's nothing much to say in this case. It's just boxes being stacked. But I think in the near future, with geometry nodes, we can simply align and stack geometry pretty easily. We already have like a bounding box, so we can stack objects, but it's not automatic. Like in this case, Spreadshop, there's one in particular that's really powerful in Spreadshop is this list item. I haven't mentioned it. List item. In this case, what Spreadshop does is taking the geometry, vertices, and polygon data and then join it into a single list, and then using list item and the index to instance the geometry. It's really powerful that you are able to do this. I think geometry nodes should be able to do this as well if it has like a proper indexing. Yeah, the rest is just me appending the geometry back using this list first and last. This is just this is actually the matrix data, very similar to geometry nodes. I think Spreadshop inside geometry nodes is going to be really quite powerful. Alright, so hopefully you find this useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.